Hi, this is Mr. Adler. Welcome back to Ciencia on Fuego. Today, we've got an experiment that I hope really floats your boat. I've got 2 cans of soda here. 1 can of Coke, 1 can of Diet Coke. Now the 2 cans are the exact same size. But will they both float? Will they sink? Will one float and will one sink? Let's find out. Let's start with the Coke. Do you think it'll sink or float? Sinks straight down to the bottom. Okay, what about our Diet Coke? Will the Diet Coke sink or will it float? Make your guess. That Diet Coke pops straight up to the top. Now this is interesting. Now the 2 cans were the same size, so what I'm seeing is sinking and floating doesn't have that much to do with volume. Volume is how much space an object takes up. This beach ball has lots of volume. It takes up more space than the Coke and the Diet Coke, and it floats. But these 2 cans have the same volume, but one floated and one sank. Okay, so it doesn't have to do with how much space the object takes up. What about how much stuff is in the cans? They don't have the same amount of stuff inside. What's in the Coke that's not in the Diet Coke? Sugar. There's about 39 extra grams of sugar inside that Coke. Maybe all that extra mass is making the Coke sink? Now remember, we've talked about mass. You measure mass with a scale. Mass describes how much matter or stuff is within an object. Maybe if you have more mass, you sink? No, that can't be right. We have big cruise ships and warships and destroyers and all kinds of boats. They're huge. They have tons of mass and tons of weight, but they float. And I've got these little pebbles here. They don't have a lot of mass at all. Almost no stuff in here, but they sink right to the bottom. So it's not quite volume that makes something sink or float, and it's not quite mass. Maybe it's both. I'm going to draw a simple model of our 2 cans of soda to see if that helps. First, I'm going to draw 2 cans with the exact same volume. The 2 cans take up the same space. I'm going to label one of these cans Coke and one of these cans Diet Coke. Here's the beginning of my model. Now I know the Coke has way more sugar, so I'm going to try to draw particles, teeny pieces of sugar, inside the Coke. Okay, and I know the Diet Coke doesn't have any sugar. It has some chemicals and some stuff in it because, the Diet Coke still tastes like something. It's not water, but there's not that much stuff in there. So I'm going to draw the particles within the Diet Coke, but just not too many. I'm noticing something interesting. In my Coke can, because of all that extra mass, all that extra sugar, all those particles of Coke are really tightly packed together. But in my Diet Coke, all of those particles, they're much more spread out. What I'm seeing here is something sinks or floats because not just of how much mass is in something, but how tightly packed or spread out that mass is. This idea is called density. Density describes how tightly packed the matter is within an object. If my mass is really tightly packed within an object, like it is within my Coke can, I have really high density, and I'm going to sink. But if my mass is more spread out, like it is in the Diet Coke can, well, then I have low density, and I float. I bet I can understand this even better if I try to make a model of my pebbles and my boat. Let's make 2 more models. When I make my model of my pebble, I'm going to draw it really tiny, because we know our pebble doesn't have a lot of space. It's quite small. It has low volume. It doesn't have a lot of mass either. So I'm not going to draw too many particles. Here's my pebble. Not too big, not too much mass. But because the pebble is so small, its mass is really tightly packed. And again, because I want to make a great model, I'm going to make sure to label that this is a pebble. Now let's compare it to a boat. My boat is huge. I'll try my best to draw it. I'll even give it a sail. The boat is way bigger than the pebble, right? That boat has huge volume, tons of volume. It takes up so much space. But because it takes up so much space, the mass within the boat is really spread out. Even though the boat takes up way more space than the pebble, it has way more volume. All of the mass inside of it is really spread out as a result. The boat has more mass, more stuff, but that stuff is so spread out that the boat has really low density, which causes our boats to float. Now, we can actually put a number on density too, this new property. The density of water is 1 gram per cubic centimeter. Now, what that means is in each cubic centimeter of water, there is 1 gram of mass. So if I sink, I must have more density than 1 gram per cubic centimeter. Think about our Coke. Our Coke not only has liquid in it, but also that 39 grams of sugar. All of that mass is packed into that liquid, so as a result, that Coke has a density of higher than 1 gram per cubic centimeter, so it will sink in water. But on the other hand, that Diet Coke, all it has is liquid and also some gas. Gases have really low density. That's why they expand to fill rooms and spaces. As a result, the density of the Diet Coke is a little bit less than 1 gram per cubic centimeter. And that means that my Diet Coke will float. We can do the math some other time, but we can actually put a formula on that. The density of any given object looks like this. Density is mass over volume, or how tight the mass is packed, the matter is packed within an object. I can do the math, or I can just describe it with my models by saying the more tightly packed the matter is within an object, the more dense an object is. Let's summarize what we've learned. We can calculate density. Density is mass over volume and come up with a number. And I know that if that density is greater than 1, my object sinks in water. And if my density is less than 1 gram per cubic centimeter, my object will float in water. But I can also describe density. Density describes how tightly packed the matter is within an object. The more tightly packed the matter is within an object, the more dense that object is, the more likely it is it will sink. And the more spread out my matter is within an object, well, the less density that object has, and the more likely it is that the object will float. I hope this experiment gives you a lot to think about. Have a great day.